Problem number 3 in the growth and decay group is going to be kind of the same verse as the first. So I'm going to assume you've seen the first couple, and let's just remember the formula that I like to give you, which is called PERT, where P of t equals P naught e to the RT. There's a lot of ways to write that formula, but I like PERT. And this, of course, would be the value at any time of the population. This is the starting population. This is the exponential, the compound interest kind of idea. Here's the relative growth rate, and t is the time. So if you remember all of those, then we're going to be able to crush this one because they only ask us a simple question. They say, a sample of something decays to 94.5% of its original amount after 1 year. What is the half-life of this sample? So when you have a look at it, they're asking you when you have 1/2 of the original amount, and then it's e to the RT, right? And they're telling us that after 1 year, it's 94.5% its original amount. So let's use that. We'll do 0.945 equals, and it's going to be 1 because the original amount is 100%. So we'll just say e to the r, t, and the t is 1 year, so we'll just say t is 1. So it's really just e to the r, right? So if I take the natural log of both sides, then we're going to get ln of 0.945 equals ln of e to the r. And the r comes out of the natural log, and the natural log of e is 1. So you get that the rate is equal to the natural log of 0.945. And now we can find the half-life because we know r. So we'd say 1/2 equals e to the ln 0.945 t. Look, we haven't done any calculus. This is actually just algebra, isn't it? I think it might be. So what do we do now? What do we do now? I think we might take another natural log. Isn't that what we should do? If I take natural log of this, then we get, we'll bring it down here a ways, ln of 1/2 equals ln of e to the ln 0.945 t. And that lets us bring this out. So we get, I'll come over to the left a little bit, ln of 1/2, kind of working like that, ln of 1/2 equals ln of 0.945 t, and then ln of e crosses out. So I think that the time is just going to be a division of that, right? ln of 1/2 divided by ln of 0.945. When I stick that into a calculator, I get about 12.27, and I think that was in years. So that should be the answer to that question. That's part A. That's the half-life. So every 12 years or so, it's half as much. They want to know next how long it takes to decay to 20%. So what's our formula? Where's our discovered formula here? I kind of wrote it here in a way, but we'll just write it out. So P equals P naught e to the RT. And we know these. We want 20% of the original, and this would be just 1. So it's going to be e to the RT. And that would be ln 0.945 t. Wouldn't it? I feel like that's correct. Is that not accurate? So if I take the ln of both sides, like this, then we should get ln of 0.2 equals, and of course it'll become ln of e that marks out again, right? So ln of 0.945 t, and then, the ln of e is gone. So t should be ln of 0.2 divided by ln of 0.945. Hey Siri, what's the natural log of 0.2 divided by the natural log of 0.945? Looks like it's going to be 28.5 years. And that makes sense because it took 12 years to get to half, so it should take at least double that to get down to 0.2. And that's how you work this out. There was no actual calculus involved in this. We didn't have to find a derivative. We just needed to understand the problem.